This is a review and preparation for the Watershed final that's coming up next week. The rules of the Watershed final, first it's open book, open notes, open internet. You can go over to the computer lab and look something up, bring all your exercises, whatever, bring a laptop to the exam, that's all fine, but you're not allowed to communicate with anybody else in class or share any materials with anybody else in class. You can look things up, but no live communications with anybody. The exam starts at 10:20 on Tuesday in our regular classroom, and it will absolutely end at 12:20 p.m. There will be several essay questions, several of them extended, which may take some time to do each one because you'll want to make notes, make an outline, and write a clear essay. So this could take as long as 2 hours to complete this final exam. And it does, I think, count 35% of your course grade. One good way to study for an exam is to review an old test. And I have a whole bunch of, or I used to have a whole bunch of old tests sitting on Blackboard. Some of them are pretty stale, and they go back to when the course was substantially different. The best one we can look at is this one, Spring 2013. It's the one that probably matches in format best to what you'll see on Tuesday and generally in content. I'll go over this test. I'll tell you the things on this exam that you won't have to answer. I'll explain the answers. Every test will have a few short answer questions to get you warmed up. This test says it's 90 minutes and 25 points. The one you'll take on Thursday will be 2 full hours and 35 points. I'll have a few true-false questions. This one says watersheds generally have spatially uniform hydrologic properties, and that's absolutely wrong. That's the reason that we need to have a GIS. Curve numbers are different across the watershed. Soil types are different. That's probably such an obvious question. You might actually have a little bit of trouble thinking of it, but it's absolutely false. And this question right here actually is the reason why we have to have a GIS to handle watershed type data. A watershed size depends on the outlets selected for analysis, and we did do delineation. The more downstream you go on a creek, the bigger the upstream area behind it. So picking the outlet, whether it's where it intersects some tributary or it goes into a bigger stream or where it goes into a lake, that will change the size of the watershed. Watershed management is a very well-defined process and can usually be approached the same way in every case. We did have that group of lessons about watershed management and watershed planning, in which we discovered that while there are general principles that apply and general processes that apply, get data, make a plan, do a needs assessment, and that type of thing. Every watershed is different, and every watershed management strategy and every water management plan will have its own character. So although there are things that are true of every watershed plan and things you always have to do, there is variation. Topography, soils, and land use are 3 key data sets, and that's pretty basic material, and yes, they are. Watershed management is dynamic and readjusting. Watershed management is part of an overall watershed approach. Watershed management needs a multidisciplinary approach. These are all clearly true statements. For your final exam, one thing that I like to do, just because I don't want to be so obvious is to repeat actual questions, what I may do is convert a question like this and keep the same content but ask you to respond to it in a different way. This question could be translated into something like, why does watershed management need a multidisciplinary approach? So the content is the same, the concept and the thinking, the pool of information is the same, it just gets asked in a different way. A watershed boundary A ridge, of course, and we can't forget that the watershed also has an outlet as part of its boundary. A stream is inside the watershed. It's not actually a boundary of the watershed. So the answer here is A and B. Let's see what else we got here. This one is, I don't know, this may have made a couple of you nervous if you looked already. We didn't do anything about project financing and the time value of money. Although that's a very interesting topic, we didn't get to it, so I wouldn't worry about that one. We did use stream stats, so and I believe we did spend the better part of a class using stream stats as a tool in the context of picking your highly impacted watershed. So you look for a creek, and then you drew the watershed of that creek. Stream stats is good. I'm a big fan of it, and this question is asked in a way that you have to indicate all the correct answers. Useful but expensive. No, we never had to pay anything. Identify pollution source areas. The stream stats itself did not identify pollution source areas. All it does is draw watersheds. Is available for all states of the USA. Many, yes, but some of them are cheapskates, and they don't have stream stats available. Can be used to compute a watershed draining to any point in New York. That's a good answer. That's what we did with it. Uses a large soils data set. The stream stats is purely based on topography, if you recall from the presentation that I made in class. Can estimate flood flows if you look deeper into it, or during lab, or remembered from lecture. Yes, StreamStat does, the one thing that it does make a calculation of is it makes an estimate of flood flows. It runs a simple hydrologic model. StreamStats provides some watershed characterization data. Yes, it does tell you how steep the main channel is and other things like that, and is often the first data development activity. This semester it wasn't. We had watersheds to begin with, but you should be clear that definitely the first activity in a watershed study is to find and define your study area, which is the watershed. So this is a true one. This is a good question that that you may get something similar to this, and this is one of those questions where I'll ask you something that you haven't seen before and see what you can come up with, and obviously I would accept a lot of different variety of answers if that were the case. Watershed inventory and watershed characterization. You might just look up the definitions of these just to give it in a brief sense, and I'm just panicking for a second here, trying to think of how I would answer this. An inventory is a completely mechanical process whereby you just gather data. Here's the soils, period. Whereas a watershed characterization is where you use the inventory to determine the problems, issues, behaviors of the watershed. So inventory is more mechanical and less thinking. Characterization is analysis. So this is just data. This is data. This is data. This is analysis. That's what I would say is the difference. Why was it necessary to teach you clip and extract by mask? Hopefully you'll have one of the basic mottos of watershed class to answer this, and that is everything that's inside the watershed counts, everything that's outside of the watershed doesn't matter. Clip and extract by mask allows you to take a large data set and isolate only those features or data that is inside of the watershed. Why and how is zoning a vital tool for watershed management? Well, I guess in this case I might as well just try and teach you something if you're actually paying attention, and I might ask a very soft general question vaguely like this. Zoning is the best way, and it's the pretty much the way that communities and control land use. And since land use management is what allows us to do watershed management, zoning is important. what does a curve number measure? I think I'm going to leave you to review your lab and think about where a curve number comes from and what it actually represents. Well, I'll tell you briefly, it represents runoff potential, and a curve number is the curve number, capital C, capital N. That specific method is based on the soil type, whether the soil drains well or doesn't drain well, whether it's thick or thin, and also the curve number depends on the land use. Principally, that'll determine how much land cover there is. Here's a very good question. Rural Kenya, which we looked at for a whole, we read a very nice article and looked at rural Kenya for a whole class and discussed a variety of things. You also viewed the Dennis Creek video, the link for which is on your Blackboard content pages. I thought, cute phrase, literally a world apart, very far apart, but they do have principles, concepts, practices, ideas, goals, etc., in which watershed management would be the same, whether one is in Dennis Creek, which is in south central Pennsylvania, Sandy Creek in Orleans County for that matter, or far away in rural Kenya. There are going to be a lot of similarities, which I hope you're beginning to detect, and that you can begin to describe to me how it's all the same, so that you can kind of see a global picture and discover that what you're doing is very applicable and useful. Let's see, discuss each of the following pictures. I don't know if I ever shouted this at you this semester in class. The most important principle of watershed management in many areas is keep the cows out of the stream, and that's what these guys have done. They're keeping the cows out of the stream with fencing and exclusion. And you might have seen this in the Dennis Creek video. One of the major projects they did in Dennis Creek watershed, one for which there was actually funding and money that they were able to get, was to keep the cows out of the stream, because they make very kind of messes, not only waste products, but chopping everything up with their heavy feet and sharp hooves. This is a very clear picture. This one is intended, and this reminds me, you really should base, generally questions are obvious what you need to answer them. In some cases though, you do want to look at the point value for a question, and if this question right here had 5 points on it, that's 5 out of 35. That makes it pretty substantial. That would be a strong indicator that you would probably want to come up with a substantial answer to this. If this was a 1-point question, you'd say, oh, that's a watershed coalition. But for 5 points, you would say much more. You would talk about what a watershed coalition is, who these people probably are, etc., etc. Let's see, another picture. Here's another picture, and this is very distinctive. We saw this in class. This is a picture of, I forgot the name of the county or the region of Kenya. I just completely blanked on that. But this is the area in Kenya at which the watershed study we discussed in class, and you read an article. This is a Google Earth picture of it, and it shows some particular characteristics that may or may not be the same as you would see in western Monroe County, New York. So whilst there are things that are the same, there are also things that are different. It's on steep slopes, it's contoured, it's probably very intensively farmed. Things might come out like the amount of effort that seems to be put into managing these fields indicates that the land there is relatively valuable, relatively expensive. Also the fact that there seem to be quite a few households in a relatively small area. If this was Monroe County, this whole area here would be nowhere near enough even to support one farm household enterprise, whereas here it looks like there's like 10 different households that are making their living off of this. So there's a significant difference. Let's see here. No more pictures. Other suggestions. I'm going to pop over to this page. Let's see, page. And I'll just remind you of another way to study. So that was it for the old exam, and that revealed a lot, both some specific items to hit, some specific questions, as well as my general way of asking you to write and create an answer. Forget not that there's a very clear set of material here. Every one of these folders has a PowerPoint presentation in it, as well as a lab. Although a question you may have, the lab exercises are a little bit de-emphasized on the final, because I did have enough opportunity to assess your GIS, lab, computation, doing maps and all that stuff by watching you in lab and by the quality of your report. So that'll be a little less, although I won't hesitate to throw in a few things, that are general things about why did you do this on some particular Thursday, general things. So we did talk about what's a hydrologic unit, and in there's what's a watershed boundary, and some very basic stuff like that. What does it mean to have a 10-digit watershed versus an 8-digit watershed? Why is that important? We talked about the National Hydrography Data Set and all the wonderful stuff that's in it. And basically that would be like the question would be something more specific, but under that umbrella. What is the National Hydrography Data Set and why is it wonderful? Topographic analysis, that points out that a very important part of watershed is topography, for the very basic reason that water flows downhill. Let's see here. We went on to discover land use and talk about now you know that the reason that land use is important is because it's something that can be controlled, and also it affects the runoff potential and the pollution generating potential. We looked at soils. We saw several ways why soils are important. We saw several ways of analyzing them. We talked about the fact that people live in a watershed, and all of these things that I'm saying is, in a way, it seems kind of short for me to be able to say in one or two sentences what we did in a whole week, but what's important is how much richness of understanding you developed, and the test questions will give you an opportunity to show that. We looked at the National Water Information System. I could ask for almost any unit. What is the National Water Information System? What does it contain? Why is it useful for watershed science? Many questions will look like that. We had Watershed Management, and there were a couple of quizzes in there even that I could steal questions from. That was handy. We talked about stream stats, and I did present some very broad discussions of what a watershed model is. I talked myself red in the face talking about what makes a good model and what doesn't make a good model. So that could be somewhat important. But the main factor in watershed modeling, I would have to say, is the fact that you can't do a 50-year watershed study in real life. For instance, you'd have to do that. And you also can't say, I'd like to set up 20 identical watersheds and see how some land use change affects, how 20 different land use changes affect each of those watersheds. So we do have to always resort to watershed modeling. And of course, I'm sure you're not going to forget the three obscene phrases of watershed science. I'll let you go back and look at those. And there's three of them now, I believe. So have a look at those. International perspective, that kind of is reflected in the Kenya to Pennsylvania or Western New York comparison. And outreach, And we did have, there was a video that I prepared, another video that I prepared, but hopefully you're kind of getting the idea of what outreach is and why it's of any use. So that's a summary of the course, and really almost every question is going to be, what is X and why is it important in watershed management and for protecting the environment or for protecting people's health or whatever about watersheds is important. So I'm going to close that there before I exceed my YouTube limit. I will send out more once I catch my breath. I will send out some more some times and suggestions for when we can meet with questions. Monday's a pretty wide open day, and that's so I'll let you know that. Right now I'm going to end the video,